Hi, welcome to Kishcatclasses. I'm Kishore Kumar. In the previous video, we have discussed something related to geometry. Geometry being the major thing in CAT, we are receiving at least 5 to 6 questions uh, out of 21 questions of quant are directly coming from geometry. So we should focus exclusively on geometry. And in the previous session, I focused on triangles, and I hope that you might have solved all the questions related to triangles. Today, I focus exclusively on circles, lines, angles. That is like angles related to lines drawn inside and outside the circles. That is like internal angles and external angles. First, I start with some theory. I probably focus on things related to lines, angles, and circles. Little later, I discuss all the problems, that is 43 problems given in the worksheet. And remember, almost 40% to 50% of the questions asked in CAT 1990 to 2008, there's like paper format. Almost all 50% of the questions are directly from applications of circles, applications of the concepts related to circles. The remaining 50%, the majority of the remaining 50% comprise of concepts related to triangles. So we have already covered very close to some 30 to 40%. Now today we are going to cover the remaining 50 percentage. So it means that by the end of this session, you should be able to solve almost 75% to 80% of geometry. It means you can easily solve some 4 questions at least out of the 6 questions that are generally asked in CAT 2013. So these 4 questions is almost equivalent to half of the sectional cutoff, and at least it is going to give you an added advantage. So let's focus on circles. So I focus on internal things related to circle, then I focus a little later on external things. There is a circle. Well, obviously you know some small concepts which are important concepts, like this is the radius. Radius is the line drawn from the center point of the circle to the circumference or the side of the circle, that is generally called circumference. So the diameter is exactly 2 times the circle. So this information is known to every candidate. The other thing is, when you draw a line inside the circle, it need not be radius or diameter. It could be some just line. Now as I have drawn line AB, this line AB is called chord. Now let's discuss the relationship between chord and radius. Now if you draw a line from center to the chord, or the passing through the chord, that is a radius, this chord can meet radius at any point, that is like it can meet here or it can meet here. But if a line is making exactly 90 degrees with the chord, that is OC is making 90 degrees with the chord, it means that the chord is bisected. Vice versa, if the radius bisects the chord, it makes 90 degrees with the chord. The next one, if you draw 2 chords inside the circle, these 2 chords can be on either side of the diameter, or these 2 chords can be on a single side of the diameter. And the other property is, if you draw 2 chords, chord 1 and chord 2, let's say that I focus on PQ, and then let's say I focus on MN. If 2 chords are equal in length, it means they are equidistant from center of the circle, and this angle is going to be 90 degrees. Equidistance means, well, the radius passes through the midpoint of the chord and it makes a 90 degrees because it bisects also. So if the two chords are equidistant from center, then the length of the two chords are equal. Vice versa, if the two chords which are uh, if the two chords, the distance from the center to these two chords is equal, then the length of the two chords are same. Now I focus on segment. Now what is a segment? Is just a fairly simple thing. If you draw a card, that is like I have drawn a card, it's like AB. Now AB is a card, however this part is called segment or arc, or generally this is, we consider it as arc. Now I focus on this segment. If you draw this, let me focus on now this segment. If it say that it is making exactly, let's say, x degrees at the center, and it is supposed to make x degrees at the center, the same segment on the same side, that is like if I draw lines like this, then this is going to be half of the angle made by the segment at the center. This segment, it means that on the same side I can draw any number of things, like this is also equal to x by 2, while this is also equal to x by 2, this is also equal to x by 2. The angle made by the segment at the center is twice the angle made by the segment on the same side on the circumference, and all the angles made by the segment on the same side of the segment at the circumference are always equal. Now let's extend this one and focus on one more common thing that is observed by majority of the students. If I draw, let's say, it is popularly known as a simple thing. Let's say that AB is the diameter of the circle and C is the vertices on the circumference. The angle C is equal to 90 degrees exactly. It is known, it is a very popular one. The triangle drawn on the semicircle makes a 90 degrees angle. That is, the triangle drawn on the semicircle is a right angle triangle. But remember, like, it's not a simple thing actually. People generally do not focus on concepts they have already learned. Look, this is people always try to remember this as a new concept. In fact, it's not a new concept. I'll correlate it actually. The previous question was just like this. Let's say AB is a segment. Let's say that this is the angle O, and let's say, let me focus on AB is also a segment, then O is the center of the circle, and then let's say a point C. So this angle C is exactly x by 2 degrees if centered angle is x degrees. Now let me focus on the first one figure. Now, what is this angle? This angle is 180 degrees. The segment made exactly 180 degrees at the center. That is why the angle made by the same segment on the same side is equal to half of it actually. So it is not that a semicircle, a triangle is drawn in the semicircle, the angle is equal to 90 degrees or it is right angle triangle. It is based on the theory we have already learned, or theorem we have already learned. Okay. Now I just focus on the other thing. Let's say, and one more popular myth, that is if a quadrilateral is drawn, if it's a quadrilateral drawn, the quadrilateral is called cyclic quadrilateral. What is a cyclic quadrilateral? Is fairly simple. The opposite angles are equal to 180 degrees. That is like if this is x degrees, then the opposite is like 180 minus x degrees. If this is y degrees, then this is called 180 minus y degrees. It means that sum of the two opposite angles are equal to 180 degrees. So if the vertices of a quadrilateral lie on the circumference of the circle, this quadrilateral is called cyclic quadrilateral. The other meaning is cyclic quadrilateral. The opposite, in a cyclic quadrilateral, sum of the opposite angles are equal to 180 degrees. I'll just prove it by taking the same thing. that as I have discussed. This is also popularly known as like the angles of in a cyclic quadrilateral, the opposite angles are equal. Some of the opposite angles are equal to 180 degrees. Let me prove this one. I have drawn two lines here. So I call this AB as a segment and C is a point here. Now its O is the center of the circle. The AB segment makes exactly x degrees here. So it means that it will make x by 2 degrees. Now observe the other one. AB is a segment, it's a minor segment. If we focus on the major segment, this is the major segment. Now the same segment, like a major segment, it made exactly 360 minus x degrees at the center. Now if you take the major segment, it makes, let's say, let me draw one more thing here. Now this is again the other side of it. It means that this is exactly 360 minus x degrees by 2, which is equal to 180 minus x by 2 degrees. Now add these two things. This is 180 degrees minus x by 2 degrees. If you add these two things, it's equal to 180 degrees. So it is not that a quadrilateral drawn inside a circle is called a cyclic quadrilateral. It is completely based on a theory we have already covered long time back. The angle made by the segment at the center is twice the angle made by the same segment on the same side of the triangle on the circumference. So we use this one to completely correlate some other thing. But some other thing is people remember it as a new point actually. It is not a new point. It is a point we have already learned. Now, okay, I just focus on another thing. Now we take a triangle. I'm still focusing on only internal lines drawn or the internal things. So it's a circle. Now if I draw, let's say I draw a geometry figure, let's say I draw a polygon. So this is a polygon. Well, polygon is any other thing, like again I've drawn one more polygon. So I've drawn a triangle inside the circle or inscribed, and I've drawn a quadrilateral. It seems to be a quadrilateral. In fact, I tried to draw a square, but it was not possible. So imagine that this one ABCD is a square, PQR is a triangle. Now in order to find the area, I can draw so many triangles. Let me focus on it. I can draw a triangle like this. Well, in fact, I can draw one more triangle inside like this. I can draw a 90 degrees one, right angle triangle also. So this angle is right angle triangle. Look, I have drawn a right angle triangle. I have drawn seems to be a scalene or isosceles triangle that is in green color. I have drawn a triangle which is in blue color. Now if you want to find the area of these three things, well, you can find, but which area is the largest or the biggest one? So in order to find which triangle has the biggest area, then the triangle must be a regular triangle. A regular triangle means all the three sides must be equal. It means the triangle which is inscribed in a circle has got more area if the triangle is a regular triangle. Regular triangle means all the sides are equal. If the triangle all the sides are equal, then it's called equilateral triangle. So an equilateral triangle drawn inside the circle has more area. Now if we focus on the second figure ABCD, I try to draw it as a square. Now square, what is a square? All the sides are equal, regular figure. Now if you try to draw any geometrical figure, like any quadrilateral like this, just focus on it actually. Now I try to draw a rectangle. You can draw a rhombus also, anything. Now if you draw a quadrilateral inside the circle, the quadrilateral which is called a regular quadrilateral, which is a square, has got the largest area. Every time, whether you draw a 3-sided figure or a 4-sided or n-sided figure, If an unsided figure is a regular figure, then it has got the largest area. Now, let me focus on the external things, a circle and its external things. A circle is drawn. Now, from an external point, you can draw straight lines, a straight line passing through the circle, a straight line just touching the circle outside. Now, first one, this one is called secant. The other thing is called tangent. Well, tangent is an important property. Secant, we get secant very rarely, questions related to secant, but quite often we come across tangent in mock CATs, particularly in CAT exam also. What is a tangent? Tangent is a line drawn from an external point to the circumference of the circular. Now, the other important point is if you draw tangents, let's say you can draw so many tangents. From an external point, you can draw only two tangents. The length of the tangents drawn from an external point to the circle, you can draw two, and the length of these two are equal. Let's say I focus on PA, PB. So PA equal to PB. And the maximum number of tangents drawn from a particular point is equal to 2. Now let's focus again on internal as well as external things. External, I know that it's a secant, and the second one is tangent. Now the internal thing. So internal thing is like I just take a point that is starting from center, that is the center of the circle. So I have drawn a line. Now obviously this is called radius. The radius makes 90 degrees angle with the tangent. So now we are focusing on the external line and an internal line. Internal line is radius. I am not taking like a chord actually. I will focus on the relationship between tangent and chord, but for the time being, let's focus on radius and a tangent. Now, if you draw a tangent to the circle, it makes exactly 90 degrees with the radius drawn to the tangent. Now on the next focus, I focus on exactly a tangent and a secant. Tangent and a secant. Look at the secant. The secant meets the circle exactly at 2 points A and B. Now here you can completely focus that on PT. I write as a PT as a tangent. Now the PT square is equal to the product of PA into PB, the length of PA into PB. The length of PT square is equal to the length of PA into PB. Let's focus on chord and then tangent relationship. I draw a chord inside the circle touching the tangent. Now, what is the relation between chord and tangent is? Let's take the angle between chord and tangent here. First thing, if the angle between a chord and tangent is x degrees, from the end of the chord actually, let's say that A and B is the chord, angle PAB is equal to x degrees. From the both ends of the chord, you draw two straight lines, and these two straight lines must meet on the circumference. That is like I have drawn AC and BC, and this angle ACB is equal to x degrees. Angle ACB is equal to x degrees. So the angle made by chord and then tangent is equal to x degrees, which is exactly equal to the angle made by the straight lines started from both the ends of the chord and meeting on the circumference. This is called alternate segment theorem. Of course, Theory is not needed. Now, if you focus on the other side actually, well, we know that one side is x degrees. If you take this other angle, you can take this angle is y degrees. Exactly, y degrees. Now, since we have drawn on the opposite side, you can draw here as well. So it means that this angle is equal to y degrees. What is x plus y? 180 degrees. X degrees plus y degrees. So x degrees plus y degrees is equal to 180. Now observe this one. This is x degrees. This is y degrees. If I arrange this card, look at this one. People generally call it as a cyclic quadrilateral. X, y. Because all the vertices are lying on the circumference. X plus y equal to 180 degrees. Which is again, this is x degrees and this is y degrees. Now focus on chord, focus on tangent. Exclusively focus on chord and tangent. We quite often we get questions from tangents and then chords. Now let's start solving the questions given in the worksheet. If you haven't received worksheet or if you haven't solved the questions, just solve and then watch the remaining part of the video. If you are yet to receive the worksheet, just send me a mail to kishcatclasses@gmail.com or else download the worksheet from facebook.com/kishcatclasses, the official page of Kishcatclasses. Once you solve, then resume the video.